Good morning, everybody. Today we're going to be taking notes on momentum. And so this is the note-taking template. You can pause and copy this onto page 9 of your notebook. All right, so our essential question for today is what is momentum and how do we calculate it? You don't have to write this down. This is just a reminder that anytime we do some problem solving, we're going to use the guess method. We're going to find our givens, determine what our unknown is, figure out which equation to use, substitute our numbers into that equation, and then solve it. We also have to remember to circle our box our final answer. That includes our units. All right, you also don't have to write this down. This was in your last set of notes. We're just going to go over this because we use velocity for momentum. So remember that velocity is the speed and direction of an object's motion, and that we calculate it by taking displacement divided by time. And we also have to include a direction like north, south, east, or west. Momentum is the product. Product means you're multiplying, okay? The product of the object's mass and velocity. So if something has mass and a velocity, velocity can be 0, by the way. It's also a way to measure how hard it is to change an object's motion. All right, so examples of changing your motion would be starting or stopping, turning, so changing your direction, speeding up or slowing down. So if it's hard to start an object moving, that means that it has a lot of momentum. So to calculate momentum, we do mass times velocity. And the symbol for momentum is a lowercase p. The symbol for mass is m. The symbol for velocity is v. All right, here's our calculation triangle. So in this case, we have p up here because momentum is mass times velocity. The units of momentum are kilogram times meter per second, right? That's because of the formula is mass times velocity. So this is a mass unit, this is a velocity unit. For momentum, we're always going to use these units. Let's take a look at some example problems. For these example problems, you can pause the video and you can copy down the problem, and then we're going to use the guess method to solve them. So the first one is, what is the momentum of a 3,000 kilogram truck that is moving south at 35 meters per second? First step is to find the givens. We have 35 meters per second. That looks like a speed, but we also have a direction here, south. So we can say that its velocity is 35 meters per second south, and its mass is 3,000 kilograms. It says, what is the momentum? That is what we're looking for. That's our unknown. So we're going to use the equation. If we cover up p, that's what we're looking for. We have mass times velocity. All right, so there's our equation. We're going to substitute in the things we know. So we're going to put a 35 where the v is, and a 3,000 kg where the mass is. And then we're going to put that in our calculator and solve. All right, notice the answer has kilograms meters per second, because that's what we had up here. But we also have the direction of south, because momentum is also a vector, because we're getting that direction from the velocity. All right, example 2. What is the mass of a ball that is moving at 40 meters per second north with a momentum of 6 kilograms meters per second north? All right, so in this one we have a given that is our momentum, right? It says with a momentum of, so there's our momentum, and we included the direction of north. And here's our velocity, 40 meters per second, and we included the direction of north. It says what is the mass? We're looking for mass. And so now we have to figure out the equation. So let's cover up mass here. We're left with P over V. So P divided by V. All right, so let's make that into an equation. Now let's put our value for P, including our units on top, and our value for V on the bottom. Notice that the direction is going to cancel out. That's good because math is a scalar, or mass is a scalar, so mass does not have a direction. And meters per second also cancels out. We're only left with kilograms. Okay, last one. What is the velocity of a 65 kilogram person with a momentum of 52 kilogram meter per second west? So our givens are our momentum, and our direction is west. The mass is 65 kilograms, and we're looking for velocity. All right, so in this case, we're going to cover up velocity here, and we're left with P over M. So we'll turn that into our equation. We're going to put our value for momentum, including units on top, and our value for mass, including units on bottom. And we can see that the kilogram cancels out, so we're only going to be left with this stuff here. So velocity will be 0.8 meters per second west. All right, we'll do some more practice on Thursday for this kind of stuff, on Wednesday, and I will see you guys soon.